I'm going to talk to you about synthetic data, creating synthetic data. And this is a topic that a lot of people keep asking about on my channel, and I keep putting it off until now. The reason why I keep putting it off is for like personal reasons, honestly. Like I don't want to dive into it. But so here we are. And like starting off, the reason why I don't like to dive into the topic is because like the majority of people, they have a fundamental misunderstanding as to how data works as a whole. And if you don't have the right framework up front, like if your misconception is flawed as to the top of the framework, like the foundation of the framework, then like the whole house is going to fall apart, right? And I can frame this to you very simplistically, but like most people don't like to understand this for some reason. I don't know, but so the meaning of data is a human construct. Whatever data means is like arbitrary, right? So a simple example of this, like very simple, cut and dry. If I give you the winning lottery numbers for tomorrow, that's very meaningful. That would mean a lot to a lot of people, right? If I could do that, I can't do it. But if I could, it would mean a lot. If I give you the numbers for lottery yesterday, and I can do this, it doesn't mean very much, right? One is worth a ton of money, one is absolutely worthless. Like you're gonna tell me to go away if I tell you the numbers for yesterday, and like you'd be offering to give me money if I give you the numbers for tomorrow, right? Those are two vastly different equations to us. But if we fed that to an AI model, it would be, so I'm filming this on 2/20/2025, according to like American calendar. And then, so I would be, the model would either recognize it as a 2/19/2025 or 2/21/2025. And that would be the difference to the LM model or to the AI model, right? Or to the computer model would be the difference in those two dates. But the meaning behind that is arbitrary, is a human construct overall. And that ties very specifically into synthetic data because synthetic data is all a construct, right? All data is a synthetic data and is a human construct if you understand that. And then so to ask like, how do you create synthetic data up front shows like a misunderstanding of that concept of how data is actually constructed. The question isn't how do you generate synthetic data. Like generating synthetic data we live in an age where you can generate synthetic data for $0. Like data is plentiful and abundant, and the data problems are solved and way overblown by any sort of media organizations, and have already been known for years now. And like there's lots of data everywhere, right? Again, what is the value of data? And then so we've been looking at this website here, right? Artificial Consumers, AI persona-based surveys, focus groups, assessments, and more. This is my company, I own it. I started this like a year ago. I had initial strong interest in this, and then I realized the problem is I have to sell this concept to people, right? Like that initial concept that I brought up, like what is the value of data? The value of lottery numbers tomorrow is worth a lot. The value of lottery numbers yesterday is absolutely worthless. And that equation comes in to play with you as well, right? What is the value of an artificial consumer versus an actual consumer? It's absolutely worthless, or it's worth 99% of an actual consumer. If you understand how it actually works, like how the math breaks down, it's worth 99% of an actual consumer. But I have to go through the work to explain that to you. And then going through the work to explain that to you gives you the work to create synthetic data overall. And then so you kind of see why I've abandoned this concept over here, right? I don't want to make it my job to teach people overall about these concepts related to synthetic data, but I'll do it once in this video. So here we are. And so highlighting this concept, before I dive into actual standard deviation and what is actually important to you that you need to understand with synthetic data, I'll answer your question for you up front, right? The burning question, what's the actual process for getting this data? Very simplistic, huggingface.co, go to spaces, type in synthetic, and here you go. synthetic data, like you have like 50 options, like maybe more, maybe 100 options. Synthetic data generators, synthetic correlations, synthetic patients, synthetic IQ, is still labeled synthetic data. Like, so again, like we live in an age where if you want to produce data, it's here. What if we like pick one of these tools? Anyone can do it. Literally anyone can do it. Here you go. And then do what type? What do you want to use it for? Text classification, chat data, or RAG? Very simplistically, configure the data set, everything that you want. Do you want multi-labeled data? How much clarity do you want it? The difficulty, you can set it like literally to high school, college, etc. Very easy to create the data, right? And then so I like before like I had my like, director roles and consulting role and all of those. I like came up as like a data analyst, right? A data scientist, data analyst, and I cut my teeth on this primarily. And then so there is a equation within this that most people don't understand, right? And then so like how good is your synthetic data? Like you can actually mathematically figure out how good your synthetic data is. Like it depends on the problem overall, right? And the question in how you do this is you measure the standard deviation within a data set compared to a different data set. Very simple. Like it's if you know how to do it and you know that this exists, it's simple to set it up. It's just like understanding data science overall. But so I'll explain this to you in simple terms here. So basic idea, like how typical is typical? Imagine you're measuring the heights of all of the students in a class. You'll find that most students are clustered around a certain average height. Some will be taller, some will be shorter, but most will be relatively close to that average. Standard deviation tells you how close most students are to that average. It's like saying, low standard deviation, most students are bundled up tightly around the average height. There's not a huge variation. Think of a class where everyone is roughly the same height. High standard deviation. Students' heights are spread out a lot. There's a very big difference between the tallest and the shortest, and many students are far from the average. Think of a group with some very short people, some very tall people, and fewer in the middle. Then you have your average or mean, the starting point. Before you can understand standard deviation, you need to understand the average, also called the mean. And the average is simply the middle value. And you calculate it by 1, adding up all of the values, so like all of the heights, or 2, dividing by the number, and 2, dividing by the number of values. So like the number of students, so number of heights divided by number of students. And then the average is the point where measuring the spread from. 3, visualization standard deviation. Imagine a bell curve, like also called like a normal deviation. And this is a common shape that shows up a lot in statistics. The peak, the very top of the bell curve, is the average, the mean. And then the spread, like how big, how wide that bell is, that represents the standard deviation. So a narrow bell curve means low standard deviation. Things are clustered very tightly together. Wide bell curve means that they're spread far apart. Wide deviation. What standard deviation tells you? Like, why does this all matter? First of all, it measures three things. Consistency. Low standard deviation means that the data points are consistent and predictable. A high standard deviation means there's more variability and less predictability within the data set overall. Outliers. Standard deviation helps you identify outliers, extreme values, values that are very far from the average or many standard deviations away are considered unusual, and you can just cut them out from a data set if you break it up this way. Comparison. You can compare the standard deviations of different data sets to see which one is more spread out. For example, you could compare the standard deviation of student heights in 2 different schools to see which school has more variation in height. A simple example, I'm not going to use any math. So let's say that you have 2 groups of dogs, and you have group A is Chihuahuas, all Chihuahuas, and their weights are all pretty close together, say between 4 and 6 pounds. And then so the average might be like 5 pounds. And the standard deviation is going to be low, maybe like 0.5 pounds. They're all Chihuahuas, they're all small, right? But let's say group B, you have mixed breeds of dogs. And then so you have some tiny dogs, some huge dogs, and then you got everything in between. And then the average weight might also be, let's say, 5 pounds, just by coincidence, right? But the standard deviation is going to be extremely high. Let's say 15 pounds. And then so that's a lot of deviation, right? Like the average is 5, but the deviation is 15, meaning that like there's a huge dogs in there and small dogs in there that are making up your average. So even though both groups could have the same average weight, the standard deviation tells us a very different story about how those weights are distributed. So key takeaways are we could essentially utilize this equation and a lot of math within this to essentially come up and figure out within a data set how many deviations it is from like our standard data set, like our example data set, right? And then so very simplistically, this is like a scientific equation that's utilized throughout, data science, data analysis, etc. And then generally speaking, if you're within one standard deviation, you're good, right? And then so within artificial consumers, I can prove out, like for example, within this, I can utilize this to say I take survey group data and you have base survey group data. I can within one standard deviation, meaning like very like 95%, 98%, have like essentially like the same type of data set and like the same type of results as you would with that via artificial consumers. And then I know how to do that because I can dial it within this standard deviation formula. And this is what matters, right? And so I'm giving you, this is the standard deviation detector. This like it's MIT licensed. You can use it. I built it out for this video. And so very specifically, what it does is it measures standard deviation within a data set, right? In this instance, I'm assuming that you're going to load CSV files and a lot of people will most primarily deal with CSV. So this is built out for CSV. And then essentially you just load your CSVs. So this is a lot of code, right? Like it's all code. I'm not going to go through all of it, but essentially you go through, and then in this instance, you have two methods. You can upload the CSV files directly if you hit this and not clear to just do that to fix that. But then you can either upload your files directly, or in this instance, I tested it with these California Housing Test and California Housing Train, right? I thought this was a good test because this is essentially the same data set. And this gives you a good example of what how this results look, right? So with a test and a train, if you're not aware, essentially the test is essentially taking say 10 or 20% of the train and then just cutting it out, right? So it's like 10 or 20% of the overall data set. So it's the same data set, and then so we expect like small deviation, right? That's what we would expect, because it's not going to be 100% identical. 20% of the data set is not 100% orthogonal to 100% of the data set, but it should be like 90%, 95%, right? And then so when we go through, that's exactly what we see here with our standard deviation detector. So it goes through and it's measuring the different features, right? And then so it'll measure mean difference in the standard deviation, the standard ratio, so synthetic versus original, KS statistics, and the p-value. And then it goes through and then essentially measures it across all of the different feature states and then returns these results. And then if you're not familiar with reading these results, we either want these numbers to either be very close to 1 or very close to 0. And then we see a lot of that all of that within this data, right? We see some in some features you get some deviation, but some mean deviation, but then even then we see very close to 1 and very close to 0 across a huge portion of the data sets, which is and every single slot of this, which is expected because it's literally the same. It's 80% of the data set and 20% of the data set, right? So again, not 100% orthogonal, but very close to, this is as close to 100% orthogonal as you're going to get within a data set. And that's what we're getting out of the standard deviation detector here. And then so utilizing a tool like this is how you create synthetic data overall, right? And then so once you have your synthetic data set, you have generated synthetic data, you have whatever you want it to build, you then figure out and you take it versus your base data set, and then you compare it. I guess like the next step from here that throws a lot of people off, I'll get off of this white screen, that throws a lot of people off within this particular thing is like, well, is my data set good or bad? And like, how exactly do I frame that? And what columns do I use, etc. Right? Like that's like kind of, I think, the next step that people want me to address within this. And that's all like going back up to the top. Like, is it good? Is it bad? Is it going to lead to whatever outcome that you want it to, etc.? All of these are human constructs, right? What are you trying to do? Are you trying to find and predict the lottery numbers for tomorrow? It's probably going to do bad. Are you trying to predict and find and predict the lottery numbers from yesterday? It's probably going to do pretty good, right? And then also remember within that, predicting, right? There's two things that these models do, and only two things that they do. They predict and they classify. And then so prediction is based off of the lottery numbers from yesterday, predict what like you think is the most probable lottery number for tomorrow. That's probable, and the model could do that. I still wouldn't invest $1, but you could, and you'd get outcome from that, right? Or it classifies. So looking over the past year of lottery numbers, the most lottery numbers, like for some reason within this data set of this last year, there's an outlier pattern where the numbers, I'm making this up, 30 and 48 come up more often, like 5% more often over the past year of this data set than any other number for whatever reason, right? And then that would be like an outlier pattern that we would detect in a class, like via a classification model and a classification algorithm. And then so in that instance, if we could combine those two as well, right? So we would combine those to clean up our data, which I've talked about before, right? So let's say that we create a synthetic data set based off of this information. We create synthetic data set for lottery numbers over the past year, and then we run it through this standard deviation detector, and we find out that it's actually very high, right? The standard deviation's too high, and we need to trim that data set, and we need to fix our synthetic data set then in that instance because we want lower standard deviation. So what we do then is models can predict and classify, right? So our predictions are off, so we need to fix our classifications. So we go into our classifications, in this instance, our lottery numbers, predictions, and then we can see those numbers that I made up again, like 30 and 48 or whatever they were. Let's say that we throw those numbers out, like just those two, because those are our outliers that we detected before, right? And so we just throw out those two numbers, and then just by throwing out those two numbers, let's say that our standard deviation in our first test is like 2.5, and then we throw out those two, and then all of a sudden it drops to like 0.8. And then it's like, oh, okay, like massive decrease just from those two variables. Like we could have, like out of 100, we pinpoint to those two, throw them out, and then it increases. We get like 30% increase in performance just from that, right? And then that's where the math in this comes in, and then where that comes in, but that's arbitrary. Like that whole scenario that I just set up is an arbitrary human construct. Again, we're just dealing with lottery numbers over a year-long period. What lottery numbers over the year-long period become the outliers, which ones need to be thrown out of the data set, etc. It's all arbitrary. It's all different. It's going to be different for each data set. I can't tell you what it's going to be 100% of the time. I don't know. I would have to look at the data, right? And then so that comes in with the second element within this, and like the big element within this that I want you to understand and take away is that like the best synthetic data for creating data, how do you create data? Is it like if you want to create synthetic data, go here again, create synthetic data, you can poof it out of thin air. Like poof it. But then if you compare it to, and you run it through this, you're going to get very, very, very high deviations. If you're just spoofing nothing, and then you're comparing it to standard real world data, right? Like if you're just like randomly pulling it out of a box, you need to adjust it and then pull the levers, right? And then so you do that by understanding and taking a look and modeling off of your real world data. So you have to have some real world data in the first place. And that's like the big thing that people start, like that's like the bajillion-dollar pyramid within like all of this right now, because it's still like no one wants to take that step. Like everyone wants it 100% for free. Like just give me like all of the data. It's like, bro, we live in an age where like literally just give me 10% of it and I'll do 90%. But you just have to give me the 10%. And then like people are still like, well, why can't it give me 100%? I don't know, dude. So that's kind of framing this overall, and then hopefully this gives you a good understanding of it and a better understanding than like I think most people would outline for you. I'll leave this like the standard deviation detector. Again, utilize this, change it, modify it, make it better, do whatever you want with it to your heart's content. MIT license. If you like this type of content, please like, subscribe. Thank you very much.